Good morning, sir. I'm Charita from ACE. I'm pursuing my BTech second year in Srinivasa Ramanujan Institute of Technology. Today I'm here to present a video on the topic synchro transmitter and the receiver. Introduction to synchro systems. Synchros are electromechanical devices used to transmit angular position from one place to another. They are widely used in control systems where accurate position indication is required, such as in aircrafts and radar systems. They are the essential components of electromagnetic torque transmission systems. They are widely used in industrial automation, aircraft controls, and military applications. Understanding their operation is crucial for designing precise control systems. What is synchro transmitter? A synchro transmitter converts angular position into an electrical signal. It typically has a rotor and stator windings that generate voltage proportional to the shaft angle. The transmitter's output is fed to a synchro receiver for accurate indication. A synchro transmitter is a device that converts mechanical rotation into electrical signals. When its shaft rotates, it generates voltages in the stator windings corresponding to the angular position. What is a synchro receiver? The synchro receiver interprets the electrical signals to produce a corresponding mechanical output. It restores the electrical signals received into a physical angular position. Receivers are designed to replicate the transmitter's shaft position accurately. It converts the electrical signals back into mechanical motion. It receives signals from the transmitter and rotates its shaft to the same angular position. Basic working principle. Both transmitter and receiver operates on electromagnetic induction principles. The transmitter's rotator angle modulates the output voltages in the stator windings. The receiver uses these voltages to produce a shaft position similar to the transmitter. The working of a synchro system is based on the electromagnetic induction. When the transmitter rotor is excited with the AC supply and rotated, it induces voltages in stator windings. These voltages are sent to the receiver, which produces torque and aligns its shaft to match the transmitter position. Construction of a synchro transmitter. The synchro transmitter consists of a rotor and a stator. The rotor is excited with the AC supply and the stator contains three windings placed at 120 degrees apart, and the way the rotor rotates, it changes the magnetic coupling, inducing voltages in the stator. It consists of a rotor mounted on a shaft and a three-phase starter windings. The rotor has a winding connected to an AC voltage supply. The stator are placed 120 degrees to produce phase differences. Construction of a synchro receiver. The synchro receiver has a similar construction with a rotor and a stator. The stator receives voltages from the transmitter, and the rotor rotates due to the torque produced by the interaction of the magnetic fields. Similar to the transmitter, it has a rotor and three-phase stator windings. The stator windings are connected to the transmitter output voltages. The rotor aligns itself with the magnetic field created by the stator voltages. Types of synchronous systems. Synchro systems are mainly of three types: torque synchro system, control synchro system, differential synchro system. Each of type is used for specific control and measurement purposes. Synchronous system use a single transmitter and a receiver pair. Differential systems employ two transmitters and one receiver for error detection. Two-phase and dual-axis systems are specialized types of for specific applications. Working of transmitter. When the transmitter shaft rotates, different voltages are induced in the stator windings. These voltages are transmitted to the receiver stator. When the shaft rotates, the rotor's magnetic axis shifts accordingly. This causes a variation in the induced voltages in the stator windings. The phase differences in the voltages encode the angular position. Working of a synchro receiver. It detects the phase differences from the transmitted signals. The rotor in the receiver aligns with the magnetic field generated by the stator. This alignment indicates the shaft's angular position. And also, due to these voltages, a magnetic field is created in the receiver, producing torque that rotates the rotor until both shafts are aligned. Voltage relationships. The voltage in the stator windings are sinusoidal and phase shifted. The magnitude of the voltages depends on the rotor position. They also induced in the stator windings depending on their angular position of the rotor. These voltages are sinusoidal and displaced by the 120 degrees. The phase difference between the voltages indicate the angle. The magnitude of the voltages determine the direction of the magnitude of torque in the receiver. Advantages of synchro systems. They provide accurate and reliable transmission of angular position. They are simple in construction and easy to maintain. They are suitable for long distance control systems. Synchro systems offer several advantages such as high accuracy, reliable operation, simple construction, and the ability to transmit position over long distances. Limitations. Some limitations include sensitivity to electrical, noise, and voltage fluctuations, requirement of AC supply, and limited precision compared to modern digital systems. Their accuracy diminishes with very high speed rotations. They require careful calibration and maintenance. Applications of synchros used in aircraft navigation and control systems, employed in industrial machinery for position feedback, radar system, ship navigation, and remote position indication systems. It is utilized in the missile and radar systems for precise targeting. Synchronous comparison with other systems. Unlike resolvers, synchros are more suitable for remote position transmission. They are compared to potentiometers and encoders. Synchros are more robust and suitable for harsh environments. However, modern digital encoders provide higher accuracy and more compact. Digital encoders are replacing synchros in the same modern applications. Synchros excel in analog control systems requiring real-time maintenance and troubleshooting. Regular collaboration includes it ensures the system that checking wiring connections, proper alignment, and verifying AC supply. That is very common issue includes signal loss, misalignment, and wear in mechanical properties. Future trends in synchro technology. Integration with digital systems for enhanced position. With advancements in technology, synchros are gradually being replaced by digital sensors like encoders and resolvers. However, their development of hybrid systems are combining synchros and resolvers. Miniaturization for use in compact and portable equipment. How they are also still used in applications requiring high reliability. Summary of key points. Synchro transmitters convert mechanical angles into electrical signals. Synchro receivers decode these signals to produce original angle. Proper understanding and maintenance are vital for system accuracy. To summarize, synchros are devices used for transmitting angular position. They consist of transmitter and receiver units and operate based on the electromagnetic induction. They are widely used in control systems due to their reliability and accuracy. Practical considerations. Ensure proper electrical connections to prevent phase errors. Calibrate the system regularly to maintain accuracy. Protect themselves, protect components from environmental factors like dust and moisture. In practical applications, proper wiring, alignment, and calibration are more important for connection and operation. Environmental factors like temperature and vibration should also be considered. And finally, conclusion. In conclusion, the synchro transmitter and receiver systems plays an important role for precise angular measurement and control. Despite the emergence of modern technologies, advanced continue to improve their efficiency and integration with digital systems. They remain reliable and effective in many industrial and defense applications to ensure their longevity and performance. The references and the further reading which I have get to record this video is from these books and YouTube links. Thank you.